Done. Hey, Algebra, how are you? We're going to do part 2 of our solving equations series. Yesterday we talked about just simple one-step equations. Today we're going to talk about two-step equations or more, but it's all the same. Okay? Again, it's a foundational part of algebra. Let's get it down and really understand it. Let me remind you of something before we start, and that is the order of operations. Some of you like calling it PEMDAS. I personally don't like that. Sounds gross. I prefer, please excuse my dear Aunt Sally. That just sounds so much nicer, don't you think? P, of course, is parentheses. E is exponents. Multiplication and division are really an equal weight. We just kind of do them left to right usually. And addition and subtraction from left to right. Okay, I want you to remember that because as we solve some of these equations, we're not working a set of numbers that they've already given us and we're trying to solve the numbers. We're trying to kind of like go backwards. It's almost like we're being detectives and we're figuring out what the variable is. So we're going to work the order of operations in reverse. Okay, I should think of some snappy little thing for that. Or you guys could do your sad MEP. How do you like that? Okay, so if I had an equation like 2x plus 1 equals 7, for instance. Just take a look at that. It's not as simple as what we did yesterday, but it's going to be the same kind of thing. And remember, we're going to work this in reverse order. So what is with the x that we want to get rid of? There's a multiplication of 2, and there's an addition of 1. Which one should we get rid of first? We're going to undo the addition first, and then later on we'll do the multiplication. Okay? Remember, reverse order. So let's undo the addition first. Remember, if we do it the long way, we're going to do the same thing to both sides of the equation. We're going to subtract 1, and we're going to subtract 1. That's going to make this go away. My way that I think of is this addition of 1, when it moves over to this side, it's going to become a subtraction of 1. Then I can erase it from this side and just simplify this. So I'll end up with 2x equals 6. Does that make sense? I moved to the other side, turned it into the opposite operation, simplified, and got rid of it here. Now what's with the x that we want to get rid of? It is a multiplication of 2. Do you remember the opposite operation of multiplication? Yes, division. So we're going to simply move this over. We can divide by 2 here and divide by 2 here, or move it over, and instead of multiplying, we divide. We end up with x equals 3. And do you remember how we check? We put the 3 in the original equation for x, and we test it out. Does 2 times 3 plus 1 really equal 7? Yes, it does. So we're good to go. Okay? Let's try one, and I'll wait for a moment, and you guys can do it there in the comfort of wherever you are in video land. Okay, so x divided by 3 minus 1 equals 17. How about that? X divided by 3 minus 1 equals 17. Try it, and I'll go back to the Rubik's Cube for a little bit. Okay. Okay, how'd it go? Anybody stuck? All right. Remember, we're going to do the reverse order of operations. What's with the x that we want to get rid of? There's a division of 3, and there's a subtraction of 1. Remember, let's undo the subtraction first, then we'll undo the division. To undo the subtraction, we move it to the other side, and we make it an addition of 1. So we end up with x divided by 3. This is gone now. And this side is going to equal 18. Now, how do we undo a division of 3? We bring it to the other side, and we make it a multiplication of 3. And what we're going to end up with is x equals 54. How many of you got it right? Be honest. All right. X equals 54. So again, stick this in our original equation. Let me kind of get the original equation looking a little better. Does 54 divided by 3, which is 18, minus 1, really equal 17? Yes, it does. So we're good. Does it make sense? All right. So keep in mind order of operations. Go in reverse order of operations. Work it step by step. It's a little bit like peeling an onion or something. You're working toward that inner layer. So we're going to peel away one layer, then the next layer, then the next layer, and then at the center is the variable all by itself on one side, and all the numbers are on the other side. Does that make sense? I'll see you tomorrow.